All right, welcome to another video. So this is going to be Nvidia certification video. It's part 4. So what I'm going to do is this. I'm going to put on a stopwatch. I'm going to start the timer and then try to make sure I'm sticking to the time that is on here. If I go twice over, fine, but I want to aim to at most be going twice over, but more ideally being on time there. So let's see where I left off. So part 3. So the next is going to be recommenders systems. So let's find where that is. Okay, so it's in the AI section. Okay, recommender systems. And it should take about 5 minutes to read. So we'll start the clock and try to stay near to that time span. So now, one thing I would like to talk about quick before doing this is my choice to pick NCA-AIDC versus another cert. And especially since we can see that that this certification specifically isn't even on the certifications tab. So that could be a problem. The one that is on there is AI infrastructure and operations. So if we look at the difference between the two of them, they're basically the exact same. If we look at the topics covered in the exam and we kind of make that so that they're lined up pretty well. So just move this up one like that, and they should be lined up almost exactly. Yeah, so we can see switching back and forth, there's only one line that changes between the two of them, and it's this last line here. So the only difference between these two exams is that the one that is listed on the certification tab, NCA-AIIO, which I was kind of, oh, maybe I should do that one. Maybe there's some significance with it being listed there, right? But even if there is, and it's kind of the preferred one, I've got all the same topics are covered, except in this one it will be talking about infrastructure and operation considerations for adopting Nvidia solutions versus data center considerations, and that's my goal, right? That's what I care about. That's where the $1 trillion is going to go. That's where the whole energy system is going to be revamped. It's for building these AI data centers. So that's really what I care about more than anything else. So if it explicitly says AI in the data center, I think that's really the best bet. And then in my experience, if you get your CCIE, it doesn't matter so much that you got it in security, that you got it in enterprise, that you got it in service provider. Whether or not you have it at all is what really matters in the end. I got my CCNA in routing and switching, and I ended up working in service provider most of my career. I got a CCNP in enterprise, and it's basically not the most important thing in the world that you're exactly trained in exactly the field you're going in. But I do think if you can get as close to that as possible, because I did kind of have to, at the beginning of my career, relearn a lot of things. And if I had, already had that knowledge, it would have been kind of nice to not have to, like for example, I veered off and I did the JNCIE SP service provider instead of just continuing to work on the same path and being able to attempt that expert level certification earlier, because all of my experience aligned with my training and build off of it rather than veering off from it. So I feel like if that were the case, I could have gone for an expert level exam earlier and kind of having the two more aligned. So But anyway, that's enough talking. I've been talking for about 5 minutes, so let's get working on this. So yep. So this is recommender systems. It should take about 5 minutes. So we'll start the clock. There we go. And what's a recommender system? Deep learning based recommender systems are driving the growth of online giants. Now, with the Nvidia Merlin application framework and GPU acceleration, they're becoming accessible to the rest of us. And this is an old article 4 years ago. Search and you might find. Spend enough time online, however, and what you want will start finding you just when you need it. This is what's driving the internet right now. They're called recommender systems, and they're among the most important applications today. That's because there is an explosion of choice, and it's impossible to explore the large number of available options. If a shopper were to spend just 1 second each swiping on their mobile app through the 2 billion products available on one prominent e-commerce site, it would take 65 years, almost an entire lifetime, to go through their entire catalog. This is one of the major reasons why the internet is now so personalized. Otherwise, it's simply impossible for the billions of internet users in the world to connect with the products, services, even expertise among hundreds of billions of things that matter to them. They might be the most human too. After all, what are you doing when you go to someone for advice? When you're looking for feedback, you're asking for a recommendation. Now, driven by vast quantities of data about the preferences of hundreds of millions of individual users, recommender systems are racing to get better at doing just that. The internet, of course, already knows a lot of facts: your name, your address, maybe your birthplace. But what the recommender systems seek to learn better, perhaps, than the people who know you, are your preferences. The key to success of web's most successful companies. Recommender systems aren't a new idea. Juicy Carlgren formulated the idea of a recommender system, or a digital bookshelf, in 1990. Over the next 2 decades, researchers at MIT and Belcourt steadily advanced the technique. The technology really caught the popular imagination starting in 2007, when Netflix, then in the business of renting out DVDs through the mail, kicked off an open competition with a $1 million prize for a collaborative filtering algorithm that could improve on the accuracy of Netflix's own system by more than 10%, a prize that was claimed in 2009. Over the following decade, such recommender systems would become critical to the success of internet companies such as Netflix, Amazon, Facebook, Baidu, and Alibaba. Virtuous data cycle. And the latest generation of deep learning powered recommender systems provide marketing magic, giving companies the ability to boost click-through rates by better targeting users who will be interested in what they have to offer. Now, the ability to collect this data, process it, use it to train data models, and deploy these models to help you and others find what you want is among the largest competitive advantages possessed by the biggest internet companies. It's driving a virtuous, cycle, with the best technology driving better recommendations which draw more customers and ultimately let these companies afford even better technology. That's the business model. So how does this technology work? And I have a lot to say about that, because my experience with recommendations is that they're not useful. They're actively harmful. Basically, I don't want something to know my preferences and to cater to my preferences and my behaviors. What I want something to do is to ensure that I'm locked into the science-based best possible behaviors and preferences. So I want to be shaped, right? I want like I don't want to be like given the worst of my desires. Like I want my desires to be shaped so that I want the recommender systems not to act based on my own preferences, and I don't even want them to act on the preferences of others. I want them to act based on science-based evidence on what makes somebody the healthiest, the happiest, the wealthiest. Like that's what I want. I want them to basically advocate as like a private, kind of like how the president has an advisory staff. Like that's how I want them to operate. And they don't operate like that now, as far as I know. All right, but here's how they work. So, collecting information. Recommenders work by collecting information, by noting what you ask for, such as what movies you tell your video streaming app you want to see, ratings and reviews you've submitted, purchases you've made, and other actions you've taken in the past. And this is one of the ways I think they should work differently. I'm not sure if that's how presidential advisors operate. I think the past of a president, especially before they were president, is probably not relevant information to gather. I think most presidential advisors are military experts or like history experts or experts in some domain of knowledge. That is the kind of information I prefer that these recommenders would collect, not my personal private information. Perhaps most importantly, they can keep track of choices you've made, what you click on and how you navigate, how long you watch a particular movie, for example, or which ads you click on or which friends you interact with. All this information is streamed into vast data centers and compiled into complex multi-dimensional tables that quickly balloon in size. They can be hundreds of terabytes large, and they're growing all the time. Hundreds of terabytes. Really? That seems really small to me. That's not so much. Yeah, because I just bought a terabyte for $100. So I could buy 100 terabytes for $1,000. Like, what? Oh wait, no, I could buy 10 terabytes for $1,000. So, I mean, for 10,000, like, this is okay. Anyway, timer. Oh, yeah, I'm already way over time. That's not so much because vast amounts of data are collected from any one individual, but because a little bit of data is collected from so many. In other words, these tables are sparse. Most of the information most of these services have on most of us for most of these categories is zero. But collectively, these tables contain a great deal of information on the preferences of a large number of people. And that helps companies make intelligent decisions about what certain types of users might like. And that, I have no problem with that. I'm okay with seeing intelligent decisions. I just feel like that's not typically what happens. I feel like people can kind of pay to put their thumbs on the scales, and you get recommended things that they should really have a clear idea that you don't like, because you spend a lot of time downvoting and reporting content only to have it recommended to you time and time again. That's been my experience with recommendations. So, content filtering, collaborative filtering. While there are a vast number of recommender algorithms and techniques, most fall into one of two broad categories: collaborative filtering and content filtering. Collaborative filtering helps you find what you like by looking for users who are similar to you. And the other thing with recommenders is, like, I don't think people watched Breaking Bad because it was recommended to them by this like Netflix system. They watched it because it was good. Like, Breaking Bad is good. Like, it's not like people are just watching whatever because something like fits so perfectly into their preferences. Like, my parents watched Breaking Bad. They don't care for stuff about drugs. Like, they're not interested in that. They watched it because it's good. It's entertaining. They didn't watch it because it was recommended to them based on their preferences, or because, like, yeah. So Sorry, I'm actually there's this book I checked out from the library, Sense Making, and there's a lot of maybe that's why I'm perhaps playing devil's advocate a bit too much, because he kind of comes down pretty hard on technology. All right, so let's see here. So yeah. Collaborative filtering. So while there are a vast number of recommender algorithms techniques, most fall into one of I don't remember reading any of this now. Shoot, did I read any of this? Oh yeah. I remember this. So the next is collaborative content filtering, collaborative filtering. While there are a vast number of recommender algorithms and techniques, most fall into one of two broad categories: collaborative filtering and content filtering. Collaborative filtering helps you find what you like by looking for users who are similar to you. So while the recommender system may not know anything about your taste in music, if it knows you and another user share similar taste in books, it might recommend a song to you that it knows this other user already likes. Content filtering, by contrast, works by understanding the underlying features of a product. If a recommender sees you liked the movies You Got Mail and Sleepless in Seattle, it might recommend another movie to you starring Tom Hanks and Meg Ryan, such as Joe versus the Volcano. These are extremely simplistic examples, to be sure, and this is exactly my point, right? It's like Sleepless in Seattle and You Got Mail are very highly reviewed and regarded movies, right? It's like the reviews of these are like the Rotten Tomato. Let's look at the Rotten Tomatoes reviews, right? So 70%, that's decent. You know, that's not nothing. It's above 50%. Sleepless in Seattle, 75%. Okay, wow. You liked these two movies that 3/4 of the people who watched them also liked. So you must have liked it because it starred Tom Hanks and Meg Ryan, right? Not because they're like halfway decent movies, right? So I think you'll probably like the movie Joe versus the Volcano, which got a 67%. It got the lowest movies of all three. So it's like, no, that's not how it works. You don't like movies because Tom Hanks is in it. You like it because it's a good movie. Like, now, is it likely to be a better movie if there's a good actor in it? Yeah, but like, oh man, this is why it takes me. Yeah, we're at the 12-minute mark now. Ugh. All right, so yeah, those are simplistic. So it's more complicated than that. I think that's an example that really falls flat on its face and shows the harm of recommender algorithms. They think they know why you're watching a movie, and as such, they show you movies that are lower quality, rather than, if you haven't watched Wizard of Oz yet, I think you're more likely to enjoy that than you are Joe versus the Volcano. So for me personally, if I've watched You've Got Mail and Sleepless in Seattle, they should recommend me a timeless, classic, universally beloved movie that I haven't seen yet, because that's what I would prefer to watch next, not something starring Tom Hanks and Meg Ryan. I just watched 2 of those movies, and I probably thought they were about 70% good. Like, not that great, but like B-tier movies. Not horrible. All right, so data as a competitive advantage. In reality, because these systems capture so much data from so many people and are deployed at such an enormous scale, they're able to drive tens or hundreds of millions of dollars of business with even a small improvement in the system's recommendations. A business may not know what any one individual will do, but thanks to the law of large numbers, they know that, say, if an offer is presented to 1 million people, 1% will take it. So while the potential benefits from better recommendation systems are big, and so are the challenges. Successful internet companies, for example, need to process ever more queries faster, spending vast sums on infrastructure to keep up as the amount of data they process continues to swell. Companies outside of technology, by contrast, need access to ready-made tools so they don't have to hire whole teams of data scientists. If recommenders are going to be used in industries ranging from healthcare to financial services, they'll need to become more accessible. And this is not a 5-minute article. I've got a lot more to read. I would say the next section is data as a competitive advantage. In reality, because these systems capture so much data from so many people and are deployed at such an enormous scale, they're able to drive tens or hundreds of millions of dollars of business with even a small improvement in the system's recommendations. A business may not know what any one individual will do, but thanks to the law of large numbers, they know that, say, if an offer is presented to 1 million people, 1% will take it. Oh, and I already read this. But, oh, right, yeah. So the next section was actually GPU acceleration. This is where GPUs come in. Nvidia GPUs, of course, have long been used to accelerate training times for neural networks, sparking the modern AI boom, since their parallel processing capabilities let them blast through data-intensive tasks. But now, as the number of data being moved continues to grow, GPUs are being harnessed more extensively. Tools such as Rapids, a suite of software libraries for accelerating data science and analytics pipelines much more quickly. So data scientists can get more work done much faster. So that's not a real sentence. Tools such as Rapids, a suite of software libraries for accelerating data science and analytics pipelines much more quickly. So yeah, okay, that's not a sentence, so that's disappointing. But anyway, moving on. And Nvidia's just announced Merlin Recommender Application Framework promises to make GPU accelerated recommender systems more accessible still, with an end-to-end pipeline for ingesting, training, and deploying GPU accelerated recommender systems. These systems will be able to take advantage of the new Nvidia A100 GPU. This is 4 years old. They have an H100 built on our Nvidia Ampere architecture, so companies can build recommender systems more quickly and economically than ever. Okay, so our recommendation: learn how to build intelligent recommendation systems. The Nvidia Deep Learning Institute offers instructor-led hands-on training on the fundamental tools and techniques for building highly effective recommender systems taught by an expert. This in-depth 8-hour-long workshop instructs participants how to... Yeah, so now they're selling me something, a DLI certificate, which I'm... Yeah, so they're selling me the thing that I'm currently already trying to get. I'll pay them $135 at some point, but I'm not taking that course. That was a really disappointing read. There was a very serious grammatical issue there. I don't know how I can downvote that or provide feedback to it, but really disappointed in that read, and it really gave a very poor example of recommender algorithms, and then it kind of drove home the point that I have, that these are quite toxic and actually work against a user. And my kind of, maybe it's a little bit of a conspiratorial opinion, but I think often all it does is it allows people to place their thumb on the scale and just force people to consume content that they wouldn't otherwise. All right, so so that didn't take 5 minutes. That took 4 times the amount that it said it would, which is bad. Very, very, very bad. All right, so the next one is accelerating and enhancing robotics with Nvidia Isaac. Okay, so we've got a video. Let's start this stopwatch and see if we can get this done. It should take 5 minutes.
It's not enough for humans to imagine. We have to invent and explore and push beyond what's been done. We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. We broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason, so it can share our world with us.
I'm not sure what they mean by we. I think they mean not you.
Is where inspiration leads us. The next frontier. This is Nvidia Project Groot.
I cannot afford this thing.
A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with Nvidia's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, Joanne. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
Am I the only one who's like just completely not impressed by that video? Like, when I was a kid, I went to Bartlett Robot World. Like, completely blew my mind to the point where I wanted to be like a robotics scientist. Like, it was like my absolute passion, but I decided, but it didn't really work out. But like, it's not that much. Like, they were doing that in. Like, it's not that different than this in the 80s. Like, I feel like it's just not that impressive. It's like Chuck E. Cheese. Okay, it can climb over some boxes. Great. How long is the battery? Okay, so that was the video. So now okay, yeah, it's a 5-minute read with like 10 different subsections. Oh my god. Okay, so shoot. Let me pause it. I'll be right back.